In late 2003, marine researchers working off the coast of Western Australia captured what appeared to be a completely healthy great white shark. She measured roughly 9 feet long, large enough to survive comfortably in dangerous waters, and far beyond the fragile juvenile stage where most young sharks struggle to survive. The team fitted her with an advanced electronic tracking tag designed to record depth, temperature, movement patterns, and environmental conditions as she traveled through the ocean. Nothing about the process seemed unusual. Scientists had tagged sharks before, and they expected the device to eventually detach, float to the surface, and transmit valuable information about great white migration routes. For nearly 4 months, everything looked normal. The shark swam through coastal waters, dove beneath the surface, hunted, and behaved exactly the way researchers expected an apex predator to behave. Then, suddenly, the data changed. Without warning, the tag recorded a dramatic spike in temperature, jumping from the cold waters around the shark to nearly 78 degrees Fahrenheit. Seconds later, the tracker plunged rapidly toward the depths, descending to almost 90.
For decades, great white sharks were viewed as the uncontested rulers of the ocean. Few animals inspire the same level of fear and fascination. Movies transformed them into monsters. Documentaries described them as perfect predators shaped by millions of years of evolution. Everything about the animal seemed designed for dominance. Adult great whites can grow longer than a car and weigh several thousand pounds. Their jaws contain rows of serrated teeth capable of tearing through flesh, bone, and thick blubber with shocking efficiency. They can detect blood in the water from miles away, sense tiny vibrations made by struggling prey, and even pick up electrical signals generated by muscle movements. They are fast enough to ambush seals from below with explosive force, launching their massive bodies entirely out of the water during attacks. For years, scientists believed adult great whites had no natural predators. Once a shark reached full maturity, it effectively sat at the top of the food chain. It hunted other animals, but was rarely hunted itself. That assumption became deeply embedded in both science and popular culture. Great whites were treated as the final stage of ocean evolution, creatures so powerful that almost nothing dared challenge them. But beneath that image of invulnerability, cracks were beginning to appear.
When the recovered tracking tag was finally analyzed, scientists expected technical problems or incomplete information. Instead, they found one of the strangest predator events ever recorded in the ocean. For months, the tag showed perfectly ordinary behavior. The shark stayed within expected depth ranges, moved through water temperatures common for coastal Australia, and followed patterns researchers had seen many times before. Then, everything changed within moments. The temperature reading suddenly spiked upward from the cold ocean water to nearly 78 degrees Fahrenheit. That detail immediately alarmed researchers because seawater at those depths could not naturally produce that kind of heat. The only realistic explanation was that the tag had entered the body of another animal. Seconds later, the tracker recorded an extremely rapid descent into deep water, plunging nearly 1,900 feet below the surface. Whatever swallowed the shark was not only enormous, but capable of diving into darkness far beyond the reach of sunlight. The temperature remained elevated the entire time, strongly suggesting the tag was trapped inside a digestive system. Then,
as researchers searched for explanations, one predator immediately became the leading suspect: orcas. Also known as killer whales, orcas are among the only animals on Earth known to deliberately hunt great white sharks. Unlike most marine predators, orcas possess extraordinary intelligence, complex hunting strategies, and the physical power needed to overpower even massive sharks. Scientists had already documented terrifying encounters between the two species in places like South Africa, where certain groups of orcas became infamous for targeting great whites specifically. In some cases, sharks washed ashore missing only their livers, removed with shocking precision. Researchers observed that when orcas entered an area, great white sharks often fled immediately, abandoning feeding grounds they had used for years. The fear response was undeniable. Great whites, creatures humans considered fearless, were actively avoiding killer whales whenever possible. So when news spread about the Australian shark mystery, many experts assumed the answer had to involve orcas. On paper, the theory made sense. Orcas are warm-blooded, which explained the sudden temperature spike inside the tag. They are large enough to kill a 9-foot shark with ease, and they are intelligent enough to hunt strategically rather than through brute force alone. But as scientists dug deeper into the data, cracks began appearing in the theory. Orcas typically target specific organs, especially the nutrient-rich liver, instead of swallowing entire sharks whole. The tracking tag, however, remained inside the predator's digestive system for an extended period, suggesting the shark had been largely consumed instead of surgically attacked. Even stranger was the depth. The mysterious predator descended nearly 1,900 feet after the attack.
Once the orca explanation started collapsing, researchers were forced to examine another possibility, one far more unsettling than killer whales. What if the predator was another great white shark? At first, the idea sounded almost unbelievable. Great whites were already viewed as apex predators, so imagining one swallowing another whole felt extreme, even by ocean standards. But the data kept pointing in that direction. Great white sharks are not completely cold-blooded like most fish. They possess specialized biological systems allowing them to maintain body temperatures significantly warmer than the surrounding water. That detail mattered because the temperature inside the predator matched almost perfectly with what scientists would expect inside a large, active great white shark. The dive pattern also aligned with known shark behavior. Great whites are capable of descending thousands of feet into deep water, especially after feeding. Unlike orcas, which usually remain closer to the surface during attacks, a giant shark could easily disappear into darkness after swallowing its prey. Researchers then compared the size estimates. Based on the data, the predator was likely between 16 and 20 feet long, an enormous animal capable of overpowering a 9-foot shark through sheer mass alone. Suddenly, the mystery transformed into something much more primal. A massive great white may have attacked a smaller great white, consumed it, and continued swimming as if nothing unusual had happened. Cannibalism among sharks is not unheard of. Several shark species attack and eat smaller members of their own kind whenever the opportunity arises. But seeing evidence of it happening between adult great whites completely changed the way scientists viewed the species. It revealed a
Even after researchers reached their most likely conclusion, the mystery was far from fully solved. The tracking tag answered one terrifying question while creating dozens of new ones. Scientists now had strong evidence suggesting great white sharks sometimes prey on each other, but they still had almost no understanding of how often it happens or why. Was the attack deliberate hunting behavior or simply an opportunistic feeding event? Do giant great whites actively search for smaller sharks, or was the victim simply unlucky enough to cross paths with a much larger predator? Nobody knows for certain. The ocean remains one of the least explored environments on Earth, especially at the depths where many large predators spend time beyond human visibility. Most shark encounters occur near the surface, where researchers can observe them. But far below, entire ecosystems operate almost completely hidden from science. The 2003 shark became important because technology accidentally captured a glimpse into that invisible world. Without the electronic tag, the shark would have vanished like countless others before it, leaving no evidence behind.
The disappearance of the Australian shark forced scientists to confront a reality far more complicated than the simple food chains taught in textbooks. Humans often imagine nature as a clean pyramid, with one ultimate predator sitting safely at the top. But the ocean does not work that way. In the deep sea,
The line between hunter and hunted changes constantly, depending on size, circumstance, territory, and opportunity. A great white shark may dominate seals and smaller marine animals one day, then become prey itself the moment a larger predator enters the area. Orcas hunt great whites. Giant great whites may hunt smaller great whites. Even massive predators live under the constant pressure of vulnerability. The ocean rewards size, power, and timing above all else. The tagged shark from 2003 became a symbol of that brutal reality. She was healthy, experienced, and perfectly adapted for survival. Yet none of those advantages mattered once something larger appeared beneath her in the darkness. The story shattered the illusion that apex predators are somehow untouchable. It also revealed how little humans truly understand about life in the open ocean. Vast regions remain unexplored, filled with behaviors, encounters, and relationships that scientists only discover accidentally through technology. The shark mystery was never really about a monster hiding beneath the sea. The true revelation was much simpler and far more disturbing. Nature does not recognize permanent dominance. Every predator exists within a larger system where survival can disappear